All right, I'm going to try to go through here to show you how to find all of these, how to solve all this stuff that was in the quiz for series and parallel circuits. I'm going to do this a little differently here. I'm going to use this, I've got a drawing pad, so we're going to try this guy. Okay, so here's what we have. I've got it on a slide over here. I've got the things back up here. So again, V equals IR. So for number one, I want to know the resistance. So R is going to equal V over I. So R equals V, 18 volts, over I. Okay, I is 120 milliamps, so that is 0.120 amps. That's the way you have to set it up. Okay, and then you just solve that. Number two, I'm looking for the current. So I is going to equal V over R. So now my V is 9 volts, and I have a 1.8 K ohm resistor. So that's times 1,000, 1,800 ohms. And then the third one, I'm looking for my voltage. V equals IR. So it's just going to be 680 times 65 milliamps. I move my decimal point 3 places to the left, and I get 0.065. So that would be the 3 formulas that I would use to find the answer. I don't have my calculator handy, but you can easily do that. All right, down here, I've already put in my resistances, and so for this one right here, so for the series, I just add them up, 2,300 plus 1,600 plus 480, and I get 4,380. 4380. That's the series. You just add them up. Okay? Now my voltage in a series never changes. So I had, if I go back to my circuit up here, it was a 12 volt circuit. Come back here. So it is just going to be, no, I'm sorry. Geez, that's not right. My total is going to be 12 volts, but this is not. But my current is going to be my voltage divided by my resistance. So it's going to be 12 volts all over 4,380. So 12 divided by 4380, and I get for this one I get 2.7 milliamps, 0.0027 amps. Okay, I have to move my decimal 3 places, so 2.7 milliamps. That stays the same everywhere. So 2.7 milliamps, 2.7 milliamps, 2.7 milliamps. Now to find this, I have to find my V equals I times R. So 2,300 times 0.0027. So I do that for each one. So for the first one, 2,300 times 0.0027, and I get 6.21. Okay, I get, 6.21. Let's see if this works out right or not. Then I have 1,600 times 0.0027, and I get 4.32. And for R3, I get 480 times 0.0027, and I get 1.3. 1.3. 6 and 4 is 10, 11, and this all add up to another one. So these add up to my total. So my individual voltages are different through each of the resistors. That's my total. Total resistance, add them up, and that's how I do the series. For parallel, now for parallel, the voltage is the same everywhere. So because I still have a 12-volt voltage, then that means my voltage everywhere here is 12 volts, 12 volts, 12 volts, 12 volts. Easy peasy. Now to find this, I have to do 1 over 2300 plus 1 over 1600 plus 1 over 480. That's a plus sign. That gives me my total. If I do that out, 2300 shift inverse plus, 2300 shift inverse plus 1600 shift inverse plus 480 shift inverse equals, and then one more shift inverse, and I get 318. That makes sense. It's less than the smallest one, so that's okay. For these, again, it is going to be V over R. So I have 12 over 2300, 12 over 1600, and 12 over 480 to get my currents in here. To find my total, that is going to be my total. I'll put it right over here on the side. I know it's getting a little crowded, but that would be 12 over 318. Let's do that one first. 12 divided by 318, and I get 0.037. 1, 2, 3. So I get 37.7 milliamps. Again, 0.037. And now if I do these other ones, 12 divided by 2300 is 5.2 milliamps. 12 divided by 1600 is 7.5 milliamps, and 12 divided by 480 is 25 milliamps. 25 and 7 is 32. That'll be 37. These all add up to this one. So my individual currents on my parallel add up. No, I went through this pretty quick, but you can pause it, look at it, make up a circuit of your own. Okay, if you want to, before you retake the quiz, is do this, do the same sheet, just change these numbers, but be aware of kilo and be aware of milli. You got to move your decimal point for this one 3 places to the left, for this one 3 places to the right. Hope that clears some things up.